Use the factor theorem to determine whether gx is a factor of px in each of the following cases. Px, in this first problem, we have px is equal to x cubed plus 3x squared plus 3x plus 1, and gx is equal to x plus 2. Now you have to use factor theorem. What does factor theorem says? Factor theorem says that if this polynomial gx, that is equal to x plus 2 in this case, is a factor of this polynomial, then p minus 2 will have to be 0. Right? What's minus 2? Minus 2 is the 0 of this polynomial gx. The 0 of this polynomial gx. And what does 0 mean? 0 means that if we put that value 0 at the place of x, you should get 0. So if you put minus 2 at the place of x, then this polynomial becomes 0. That's why minus 2 is the polynomial of this polynomial gx. And if this is a factor of this polynomial, that is px, then the 0 of this polynomial, if you put the 0 of this polynomial at the place of x in this polynomial, then this polynomial should be 0. That's what we have written here. So put minus 2 at the place of x in this polynomial, you get minus 2 cubed plus 3 minus 2 squared plus 3 minus 2 and plus 1. So minus 2 cubed means minus 8 plus minus 2 squared means 4 multiplied by 3 is 12. 3 multiplied by minus 2 is minus 6 and then plus 1. From here, minus 8 plus 12 is 4, minus 6 is minus 2, plus 1 is 3. Of course, this is not equal to 0. Therefore, since p minus 2 is not equal to 0, therefore, x plus 2 is not a factor of this px. Okay, in the same way, for the second one, your gx is equal to x minus 3. So if gx is equal to x minus 3, it means that its 0 will be 3. Because if you put 3 at the place of x, this polynomial becomes 0. Now find out p3. So p3 is 3 cubed minus 4 multiplied by 3 squared plus 3 plus 6. This gives you 27 minus 4 multiplied by 9. 4 multiplied by 9 is 36 plus 3 and plus 6. 27 minus 36 is minus 9 plus 3 is minus 6. Minus 6 plus 6 is equal to 0. Yes, p3 is equal to 0. That's why x minus 3 is a factor of this polynomial px, that is equal to x cubed minus 4x squared plus x plus 6. Determine which of the following polynomials has x plus 1 a factor. Same question as we have done here. What we have done here. If x plus 1 is a factor of this polynomial, then the 0 of this polynomial is what? Minus 1. So in this case, let's say that this is px, and this is also px. This polynomial is also px. So if you put p minus 1, then if this is a factor of this polynomial, then p minus 1 should become 0, should be 0. So put minus 1 at the place of x, you get minus 1 cubed plus minus 1 squared plus minus 1 and plus 1. This gives you minus 1 plus 1 minus 1 plus 1. Yes, this is equal to 0. That's why x plus 1 is a factor of this polynomial. What about this one? If you find out p minus 1 in this case, you have minus 1 cubed minus 1 squared minus 2 plus root 2, square root 2 multiplied by minus 1 and plus root 2. From here you get minus 1. Now you have minus outside, and minus 1 whole squared means what? 1. So this is minus 1. And now you have, this is minus 1. So minus 1, and you have already minus here. It means that this becomes positive, right? This is minus 1 and here you have minus. So if you open the bracket, this becomes positive. So plus, and then you have 2 and plus square root 2. We have simply opened the bracket. Okay, now this becomes square root 2. Okay, this becomes square root 2. Now this is minus 1 and minus 1, that is minus 2. Minus 2 plus 2 is 0, and then you have square root 2 plus square root 2, that is 2 square root 2. Sorry, you have, yes, you have 2 square root 2, right? Root 2 plus root square root 2. That's why this is not equal to 0, and hence x plus 1 is not a factor of this polynomial. Find the value of k if x minus 1 is a factor of px in each of the following cases. Again, the factor theorem says that if a polynomial is a factor of another polynomial, then the 0 of that polynomial, if you put the 0 of that polynomial in this main polynomial, then that polynomial should be reduced to 0, and we'll use the same thing. X minus 1 is a factor of this polynomial px. What's the 0 of this polynomial? If this is, let's say that this is gx is equal to x minus 1. What value should we put at the place of x so that this gx becomes 0? Clearly, if you put 1, so 1 minus 1 will be 0. Therefore, the 0 of this polynomial is 1. Now, what's in the case? Now, since it's given that it's a factor, it means that if you put the 0 of this polynomial at the place of x in this polynomial, then this has to be equal to 0 according to factor theorem, right? 0 of this polynomial, that is a factor of this polynomial. If you put the 0 in this at the place of x in this polynomial, you should get 0. So put p1, this is 2 multiplied by 1 squared plus k, we have to find its value, multiplied by 1 plus square root 2, this is equal to 0. Right? Now this is 2 plus k plus square root 2, right? So from here you get k is equal to minus 2 minus square root 2. Now if you want this to take this negative sign outside, you can write this as minus within the bracket 2 plus square root 2. If you want to further simplify it, you can put the value, you can take the value of square root 2 and you can add this with 2, right? If you want. What about this one? Again, x minus 1 is a factor of this polynomial. It means that if you take the 0 of this polynomial, that is 1, and if you take this 1 and put at the place of x in this polynomial, then this has to be equal to 0 according to factor theorem. So p1 in this case is k multiplied by 1 whole square minus square root 2 multiplied by 1 plus 1, and this has to be equal to 0. So k minus square root 2 plus 1, this is equal to 0. From here you get k is equal to square root 2 minus 1. If you want to further simplify it, take the value of square root 2 and then subtract 1 from square root 2 and you'll get the result, right? So this is the way to calculate the value of k.